solve the given OD, you are given d squared plus 4 into brackets y is equal to 6 sine of 2x plus 3x squared. So to do this, first of all, we are going to have the complementary part. The complementary part will be d squared plus 4y, which is equal to 0. So to solve this, you note that d squared is the same as y double prime, and the d single prime is the same as y prime. Then we are going to let our y to be equal to exponential mx, so that now we get our y single prime is equal to m exponential x, and our y double prime is equal to m squared exponential mx. So substituting there, we are going to have m squared plus 4 into bracket exponential mx being equal to 0. Now from here, it follows that exponential mx cannot be equal to 0, meaning that our m squared plus 4 is the one which is equal to 0, which implies that m squared is equal to negative 4, meaning that m is equal to square root of negative 4, which is equal to 2i, which gives you plus or minus 2i. So our complementary part will be y complementary will be given by a1. We can use a1. We can use a1 sine of 2x plus b cos of 2x. Now, to obtain the particular part yp, we are going to attempt this form: x into bracket a sine of 2x plus b cos of 2x, then plus cx squared plus dx plus a. So we are going to attempt the particular part of this form. Then from here, you get your y p prime, which will give you a sine of 2x plus b cos of 2x by product rule. Then from there now, you differentiate this other part here with respect to x to obtain the following: plus x into bracket, you differentiate this will give you 2a, it will give you 2a cos of 2x minus 2b sine of 2x, that way. Then plus 2cx plus d, that part. Then you differentiate this again, y double prime, this will give you 2a, that will give you 2a cos of 2x minus 2b sine of 2x, plus you differentiate x, you want what is remaining constant, 2a cos of 2x minus 2b sine of 2x. Then you want now x constant as you differentiate the inner part. So you will have plus x into bracket. This will give you negative 4a sine of 2x minus 4 minus 4b cos of 2x. 4b, this is 4b. Then you differentiate this, plus 2c. So from this one, we see that we have negative 4ax sine of 2x, and also we have this other part here which is positive, so this part and this other one will cancel. Also we have 4bx cos of 2x, and also we have this other part here. So our equation will reduce to 4a cos of 2x minus 4b sine of 2x. Yeah, note that this part have cancelled, plus 2c plus 4c x squared plus 4d x plus 4a is equal to 6 sine of 2x plus 3x squared. So we are going to equate the coefficient. When you consider the left hand side and the right hand side, there is no coefficient of cos on the right hand side, meaning that this part here, 4a is equal to 0, which implies that our a is equal to 0. We compare this now to our coefficient. The coefficient of sine of 2x, we shall have negative 4b, which is equal to, here we have 6, meaning that our b is equal to negative 3 over 2. We also compare coefficient of x squared. So when you compare, you can see here we have 4cx squared, and here we have 3x squared. So comparing the coefficient of x squared, we shall have 4c being equal to 3, meaning that our c is equal to 3 over 4. Considering the part of 2c plus 4e, on the right hand side, we don't have a part without the x, so this one is equal to 0. Then we have found the value of c. So our value of c is 3 over 4. So here we shall have 2 into bracket 3 over 4 plus 4e, which is equal to 0. Meaning that here you have 3 over 2 plus 4e is equal to 0. So from here, you can clearly see that 4e is equal to negative 3 over 2. So e is equal to negative 3 over 8. Now, so we have obtained our constant. We have obtained our constant as a is equal to 0, b is equal to negative 3 over 2, c is equal to 3 over 4, e is equal to negative 3 over 8. The other part is d. D is equal to 0. Why? Because here, where you have x on the, from this part here, you have 4 dx. On the right hand side, there is no part with x, so that is when d is equal to 0. Meaning that we annihilate our particular solution, yp, to be of the form x into bracket a sine of 2x plus b cos of 2x plus c x squared plus d x plus e. So substituting this constant, we shall have yp is equal to x into bracket. The first part here will become 0 because a is 0, minus our b is 3 over 2 cos of 2x. Our c is 3 over 4, so close the bracket there, plus 3 over 4x squared. Our d is 0. Our e is negative minus 3 over 8. So which can be written as our yp is equal to negative 3x over 2 cos of 2x plus 3x squared over 4 minus 8 or 3 over 8. So that is our particular solution. Now, combining this one with our complementary solution, so our general solution y will be given by yc plus yp. Our own g was of this form. It was y double prime plus 4y plus 4y, which was equal to on 6 sine of 2x plus 3x squared. So now our answer will be y is equal to, our complementary part, we found it to be equal to, c1 sine of 2x plus c2 cos of 2x. Now plus this other part here now. So it will be minus 3x over 2 cos of 2x plus 3x squared over 4 minus 3 over 8. So that is our solution of our given OD. So thanks so much for taking your time to study with me. For more such learning, kindly tune on to my YouTube channel so that we may continue learning together. Bye bye. See you in the next studies.